Hey, so just waiting for the grade 9, 10, building your math foundations to get in the room today. We start the session at 3 p.m. to 4:30. Today it will be algebra. So what you'll notice, the way I do algebra is a bit different than how they show you here. I think my method is more effective, faster, and I call it modern man algebra. Okay, so let's wait for everybody to get in and then we'll get started. So Ibrahim, so the first few slides, I said, if you have x minus 2 equals 5, what I do, I go x equals, I move the negative 2 to the other side. When I move it to the other side of the equal sign, it becomes plus 2. So x equals 7. I don't do plus 2 to both sides. I just say the minus 2 moves to the other side of the equal sign, becomes plus 2. Okay. If you're using an iPhone to watch this, that's not the best idea. Okay. Now, also I said, if you have 3x minus 3 equals x minus plus 5, you could simultaneously, equals, that's equals right there. So you could simultaneously bring the x's to one side and bring the numbers to the other side. Hold on a second. Just give me a second there. So here what I meant, if you have 3x minus 3 equals x plus 5, you go 3x, you bring this x to the other side, it's a plus here. When you bring it to the other side, it changes to minus. Keep the 5 on the right-hand side of the equal sign. When you move the negative 3 to the other side, it becomes plus 3. So now we have 2x equals 8. Divide both sides by 2, x equals 4. Okay. Now, the other thing is, just going to clear this slide right here. Also, if I have x over 3 equals 12 over 6. Even though 12 divided by 6, you could make it 2 right away and all that stuff. So that's another way. Or you could just cross multiply the 3 there. So when you have this kind of situation, the 3 could cross from the bottom, goes to the top, and then becomes x equals 12 times 3, which is 36 over 6, which x equals 6. Also, you could go x over 3 equals 12 divided by 6 is 2. So you could do it in steps. And now just cross multiply the 3. The 3 is on the bottom, it crosses to the top. Remember, 2 is on top of 1. So that's why we call it the top. And that 4x gives me 6. Both of them are the same. I would have done it this way because I know that 12 divided by 6 I could do right away. Okay. Here I'm going to do the first one, and I'm going to let you do the second one. Always when you're doing algebra, you're trying to isolate for the variable, which is the x. The only problem right here, x is on the bottom. So if I isolate it and it's on the bottom, it's like I've done nothing. However, what you could do, you could say, I'm going to cross the x there. But at the same time, the 3 will cross where the x is, and the 5 will go there. So 5 times 6 is 30. That's crossing the 5. But the x, they're going to swap places, the x and the 3. The x crosses to the top, and the 3 crosses to the bottom. So I have the 3 here equals, and the x went to where the 3 is, so x is on top. 30 divided by 3 is 10 equals x. So let me go back to this right here. So algebra means isolating the variable. We have an unknown, which is the x, and I want to isolate it. I want it to be by itself. In these situations here, it's very easy to isolate the x if you're using the cross multiplying the way I use it. I said anything when you have this kind of situation, see one thing here, one thing there, one fraction here, one fraction there. When you have this kind of situation, anything could cross the equal sign by, if it's on the bottom, it goes to the top. If it's on the top, it goes to the bottom. So the x here is on top, so I want it to stay there. But the 6, I don't like it being there, so I need to cross multiply it. So it becomes 2 times 6. The 3 stays where it is, and now the x is automatically isolated. So 6 times 2 is 12. 12 divided by 3 is 4. 4 equals x. So now you follow this, Yusuf, don't you? Like it's easy now. It's you're finding this that maybe makes more sense. You could do it. So I need to see yes from you, Yusuf. So I move on to the next slide. Okay, good. Now we go back here. It's not only you, Yusuf, that maybe didn't get. Where am I? What happened there? Okay, sorry, I gotta go on to the next slide. You don't have to switch everything because you remember, you want to isolate the variable. You want the variable to be by itself. So we want the x to be by itself. It's good, very good question. Muhammad Rahmeda, that's very good question. Why didn't the 5 and the 6 switch? So switching is to isolate the variable. I want x to be by itself. And if x is on the bottom, I don't want it to be on the bottom. Because if it's on the bottom, it's tough. I cannot do it. But x also could cross. So if the x crosses, the equal sign, if it's on the bottom, it's going to go to the top, isn't it? But within the same time, I want the 3 not to be there either. So the 3 could cross at the same time. It's on top. It's going to go to the bottom where the x is. And then the 5 crosses this way as well. And therefore, see, the 5 crosses to the 6. The 3 crosses where the x is. And the x crosses where the 3 is. And that's what you get. Sorry, that's the x. So we have 5 times 6 is 30. 30 over 3 gives you x. 2 over x equals 3 over 9. Now, the way that a lot of teachers, they do this, cross the 9 there, cross the x there. So 9 times 2 is 18. X times 3 is 3x. Now divide both sides by 3 by 3. 6 equals x. So that's the way, most likely you've seen it before. That's the way that you're most comfortable with. But you could also go, okay, 2 over x. That's fine. Equals 3 over 9. Now I want to isolate the x in one time. I'm going to move the x there. The 3 moves where the x is. The 9 moves there. So cross multiplying. The 9 crossed. When it crosses, it's on the bottom. It goes to the top. The x crossed. When it's on the bottom, it goes to the top where the 3 is. And also the 3 wants to cross simultaneously. It's on top. It goes to the bottom. So I have 9 times 2 is 18. The 3 crosses to where the x is. The x crosses where the 3 is. So you have x equals 18 over 3, which is 6. We're all saying the same thing, like both of these are the same thing, but you could do it a lot faster. And that's what I'll be doing. And while I'm doing this, you could always do this if that's what you're comfortable with. But this is what I do. I do it really fast. Cross. If you could cross, but if you're on the bottom, you go to the top. If you're on the top, you go to the bottom, and all of that stuff in these kind of situations. Okay. So I'm gonna erase this. I know you're almost there, but it's still kind of what's going on? Things flying all over the place. I don't see where everything has gone. So here, the x is on the bottom. I want it to cross to where the 3 is. And also I want the 3 to cross where the x is simultaneously. And the 5 crosses to the 6. So that gives me the 5 times the 6 there gives me 30. And the x and the 3, basically they're swapping places. So the 3 goes there and the x goes to where the 3 is. Again, x is on the bottom, went to the top because the 3 is on top, and 3 is on the top, it went to the bottom. And therefore it's 10 equals x. The other way is 5 times 6 is 30. X times 3 equals 3x. And then divide both sides by 3 by 3. X equals 10. So that's the other way. Now here, I want to isolate the x again. The x is on the bottom. It's the unknown. That's what I'm looking for. That's what I'm trying to solve for. The same thing. I want x to cross just because it's on the bottom. When x is on the bottom, it has to cross. It crosses where the 12 is. 12 is. Okay, sorry. And 12 crosses where the x is. And the 5 crosses to the 4. So now when the x goes to where the 12 is, then you'll have equals 5 goes to where the 4 is and gives me 20. And 12 goes to where the x is right here. And that's done in one step. The other way, it's 12x because you're crossing the x there and crossing the 5 there equals 20. Divide both sides by 12 to solve. X equals, you reduce 4 goes into 12 3 times, goes into 20 5 times. So the same thing here. Now we have 20 over 12, always fractions, we have to reduce them. So 4 goes into 12 3 times, goes into 20 5 times. So as you see, both of these methods work. This is faster. Yeah, that's fine. Like if this is tough for you to follow, you could do it this way. That's fine. All right. So now I'm going to move on to the next slide. And things now are going to get more complicated because now we have the first slide, which is this one, and the second slide combined. So we have both of these combined. So earlier I said, when we have things that are added and subtracted, so here, the 6x has a -3. You're used to add 3 to both sides. But for me, I say to you, this becomes 6x equals 15. When you move the -3 to the other side, it was a -3 here. On the other side, it becomes +3. That's the first thing that I'm telling you. So 6x equals 18. At this stage here, you divide both sides by 6 by 6. So x equals 3. Yusuf, does that make sense now? Okay, good. Here, 5 minus 5y equals 10. Because it's minus 5y, I always like working with positive numbers. So what I'm going to do, I'm going to move the negative 5y to this side, and I'm going to move the 10 to this side because I want the y to be by itself. So that's the first step I'm going to do. Of course, when I move things to the other side in this kind of situation, I have to change the sign on the 10. So when the 10 moved to the other side, it was positive. When it moved to the other side of the equal sign, it became minus 10. And the negative 5y, when it goes to the other side of equal sign, it becomes positive 5y. Now 5 minus 10 is negative 5 equals 5y. Now divide both sides by 5 to isolate the y, and you get y equals negative 1. Okay. Now I'm going to go to this one right here. This, Lasse students don't like fractions, so they want to get rid of the fractions right away. So if you want to get rid of the fractions here, what you do, you multiply everything by the common denominator. And the common denominator here, everything is over 1, and this is 1 over 5. The common denominator is 5. So when you multiply this here to here, you multiply it into here, 5 times 3x will give you 15x. Minus, when you multiply a number to a fraction, you only multiply it to the top. So that becomes 5 over 5. And then you multiply it also to the 4, and that gives me 20. So now this becomes 15x minus 1 equals 20. After that, we're going now to this stage right here. This becomes 15x equals 20 plus 1, because when you move the minus 1 to the other side, it becomes plus 1. So that gives me 21. And at this stage, you divide both sides by 15 to get rid of the 15 there. X equals 3 goes into 21 7 times, and 3 goes into 15 5 times. So 7 over 5. I'm going to go on to the next one. I know some of you may be looking at this and saying, what? But put all your energy and focus on the last one right here. Lots of students, from my experience, they don't like fractions. So they want to get rid of the fractions right away. To get rid of the fractions, you got to look at the lowest common denominator here. So this is over 1. So just these two, the 3 and the 4, the lowest common denominator is 12. So you multiply all terms here by 12. 1, 2, 3 terms, you all divide and multiply them by 12. And when you multiply a whole number to a fraction, you only multiply it to the top. So the 12 only gets multiplied to the 1. So that will give me 12 over 4x minus 12 times 2 is 24 over 3 equals 12 times 2 is 24. Now see, 12 divided by 4 gives me 3x. 24 divided by 3 here, it gives me 8 equals 24. Now we have 3x equals 24 plus 8. You remember I said if you move the negative 8 to the other side, it becomes plus 8. Now I have 3x equals 24 plus 8 is 32, I guess. And at this stage, I just have to divide both sides by 3 to isolate the x, and x equals 32 over 3. Now, I think Jude was just out, and I'm going to do it one more time. So when we have fractions like this, easy way to do this is get rid of the fractions by multiplying everything by the common denominator. The common denominator between the 4 and the 3, the lowest one is 12. So what we do, we multiply everything by 12. Remember what I'm going to say now. When you multiply a whole number into a fraction, you only multiply it to the top, never to the bottom. That's where some kids get stuck, to the top. What, can anybody tell me why I'm multiplying by 12? Okay, you don't have to tell me, because I want to get rid of the fractions. I don't want fractions. I don't like fractions. Okay, Jude, so we multiply everything by the common denominator, which is 12, and you multiply a whole number to the fraction, you only multiply it to the top. So 12 times 1, we're going to get 12 over 4x. And to the top here, minus 24 over 3. And 12 to the 2 gives me 24. 12 divided by 4 here is 3. See how you get rid of the fractions? Minus 24 divided by 3 is 8. So that got rid of the fractions for me, equals 24. 3x equals, when you move the negative 8 to the other side, becomes plus 8. So 24 plus 8 is 32, because that's how I want you to start doing them in the future. And here we got 3x equals 32. So we have to divide both sides by 3 by 3. This reduces, and then x just equals 32 over 3. Can we reduce? No, we can't, because 3 doesn't go into 32, and 3 is a prime number. So that's the final answer. I'm going to move on to the next slide, because yeah, this is let me see how many slides we have. Okay, so I'm gonna finish these two slides, and then we're gonna stop with that right there. Okay, so here's another one. All the other ones, we had only one variable on one side. The variable was only on one side, so it was easy to isolate that variable. But now we have the variable on both sides. Okay, so now let me just take you back and pay attention. Let me take you back here. In this kind of situation, I said if you move to the other side of the equal sign, if it's a plus, it moves to the other side of the equal sign, changes to minus. And if it moves to the others, and if it's a minus and it moves to the other side of the equal sign, it changes to plus. We're going to do the same thing with this slide and make this question go really quick. 5x minus 3x equals 4 plus 2. It's as simple as that. Did anybody see the simplicity of this, or did I lose you? How many people did I lose? If I lost you, just let me know that I lost you. Yusuf. Okay, so remember what I said in the first slide? I said, if you move to the other side of the equal sign, not when it's like this, you know, not when it's like this, because this now, you know, this situation, hold on a second. Yeah. So in here, this situation here, there's no adding or subtracting. This here, just one fraction. It's cross multiply the 5 there, x equals 10 over 4, which is 5 over 2. So that kind of situation we talked about earlier. Here, in this one, in this question right here, is the first step we do is the first slide. The first slide said, you're free to move to the other side of the equal sign. But if you're plus, you have to change to minus. And if you're minus, you have to change to plus. So if you go from the left to the right, and the sign that you had originally was a plus, you change it to minus. If it was minus originally, when you move to the other side of the equal sign, it's a plus. So that's why I could do this simultaneously. I want to solve for the variable x. If I want to solve for the variable x, then I have to bring the x's to the left side and bring the numbers that don't have x's to the right side. I'm going to do this simultaneously at the same time. So 5x, the 3x is moving to the left side. The 3x is positive. If it moves to the other side, it becomes negative. So it becomes minus 3x. The 4 is still on the right-hand side of the equal sign. If the negative 2 has to move, and when it moves, it's negative. It moves to the other side, becomes plus 2. Now I have 2x equals 6. Divide both sides by 2 by 2. X equals 3. Now, Yusuf, let me know if that's clear, or I'll go over it again. Doesn't matter. I'll go over it again. Okay. It's easy, man. When it's like this, you know the other way? Oh, add a 2 here, add a 2 there. So now 5x, you're slower than the turtle, equals plusing 2 on both sides. So that's 4 plus 2 is plus 6. Oh, what are you doing? Oh, okay, minus 3x, minus 3x. That gives me 2x equals 6. I cross these out. Now I divide both sides by 2 by 2. X equals 3. I'm doing the same thing, but I'm doing it faster. I don't mean to make fun of anybody. I know that's the way you learned it, everybody, but you're in this course that I'm doing with you guys to sharpen up your algebra. So just know in this course, you're going to be open to different ideas. And why I'm doing it this way? Because it will make your life a lot easier when you get ahead. In grade 11 and grade 12, if you learn this way, you say, wow, you know, now I could fly through things. I don't even have to think about them twice. This is slow. This plus 2, bang. Minus 3x, bang. And then that's too slow. At the beginning, you should understand that that's what's being done, but then you should understand that it could be done a lot faster. Beautiful. Okay, so here, now, the property of distribution. So when we have 4, x minus 3, because I know I have some students in grade 8, they haven't seen this stuff before. So when we have this situation, what it means, the brackets here, it means 4 multiplied inside the brackets. So if it's 4 multiplied inside the brackets, that means I have to distribute the 4 here and here, multiplied to both of these. When I multiply to both of these, 4 times x is just 4x. So when you multiply 4 and x, you just get 4x minus 12. Okay, so that's what's going to happen here. We have 4x minus 12 equals negative 2. 4x equals 10. Divide both sides by 4. By 4, therefore x equals 2 goes into both of them, 5 over 2. I went a bit faster here. Okay, so I moved the negative 12 to the other side, became plus 12, negative 2 plus 12 is 10. And then I divided both sides by 4, and that's what I got. Okay, so I'm just gonna add another one here just so that something similar to what I'm doing here, okay? So I'm just gonna add another one, and I'm gonna write it in what color? Okay, in red. Okay. 3 minus x equals negative 2x plus 6. Hold on a second. Hold on a second. Just give me 1 second here. Maybe let me just get rid of that. Okay, so 3 minus x equals 2x plus 6. So as I said earlier, in algebra, you cannot just guess what x could be, because when it gets complicated like this, it's not as easy to see. You cannot see it fast enough. Okay, so here what I'm gonna do, I'm gonna move the x's to one side, and anything that has an x to one side and anything that doesn't have an x to the other side. So some of you like to move the x's to the left side, so you're gonna move the 2x to the left side and make it minus 2x. But me, I don't like that. I like the x's to be positive. There is nothing wrong with that, though. You could still do it this way. So I'm gonna move the x's to the right side and move the numbers to the left side. So I have to keep the 3 here. Okay, so the 3, I'm gonna keep it here. I'm gonna move this 6 to the other side of the equal sign, becomes minus 6. Equals, the 2x stays on the right-hand side of the equal sign, but that negative x is gonna move to the other side of the equal sign, so it becomes plus x. And therefore, 3 minus 6 is negative 3. Equals 2x plus x, so that's 2x plus 1x is 3x. And at this stage, just divide both sides by 3, x equals negative 1. That math is not memory, remember. Math is steps and logic. So this math is not memory at all. It's always, don't memorize math. Always try to see how we're maneuvering with things. And that's why you should be able to adapt to different ideas. Even the steps, because the math, one step leads to another. Don't memorize steps. Steps lead to one another. That's how it works. Practice, exactly. And I'm going to send you a lot of homework on this. So just try to do it with the answer key, and then you could go back and look at the answer key and make sure you got yours right. Now, Yusuf, let me know if you want me to go over this again. But Muhammad, do you want me to go over this again? This one right here. Okay. So that's a yes. Good. So we'll look at 2 different options. Okay. An option, we're going to do it right here. And the way I like doing it is going to be on the left side. So for me, I want to bring the x's to one side. Also, I want to bring the numbers that don't have x's to one side. So what makes me happy is to put the equal sign there. And I say this, since this 2x is positive, I'm just going to keep it there. And also the 3 here, I'm going to keep it here. I like the x's to be positive. So what I'm going to do, I'm going to bring this negative x to the other side of the equal sign. So if it comes to the other side of the equal sign, it has to change the sign. So it becomes plus x instead of minus x. And also this 6 here has to move to this side. And if it moves, it has to become minus 6. So now 3 minus 6 gives me negative 3. And 2x plus 1x gives me 3x. And at this stage, I could just divide both sides by 3, x equals negative 1. So now, Muhammad, is that clear, or are you still? Okay, good, good, beautiful. Now we're going to go to the last slide, which is the first question is not bad, but this question is a bit hard. When we have good 20 minutes or so to do these 2 questions. So Jude, I know you haven't done a distribution method, but here the first thing we have to do distribution, which is distribute the 3 here and here, and distribute the negative 2 here and negative 2 there. So simplifying as we go. 3 times 1 is 3. Minus 3 times x is 3x. Equals negative 2 times 2 is negative 4. Negative 2 times negative x is plus 2x. Remember, this is a negative. When you multiply a negative into a negative, it becomes plus. Now, again, I like the x's to be positive. So what I'm going to do, I'm going to go 3. I'm going to bring the negative 4 to this side, becomes plus 4. I'm writing the answer first. Plus 4 equals the 2x is on the right-hand side of the equal sign. It doesn't matter if it's here or there, just it's still on the right-hand side of the equal sign. And I'm moving the negative 3x to that side, so it becomes plus 3x. Now 7 equals 5x. And then you know that we have to multiply everything by 5 to isolate the x. So by 5, x equals 7/5. Please let me know if you want me to go over this again. We have a lot of time, so don't be shy, just ask. Yusuf Hassan. Now, this one, I said maybe it's hard, but not really. It's not that hard. So when we have fractions, to get rid of fractions, I have to multiply everything by the common denominator. The common denominator between 4 and 6, because these are the only fractions, between 4 and 6, that means I have to multiply everything by 12. The 12 here, once you multiply it into here, then eventually it's gonna get multiplied into there, because that's the distribution property. It doesn't allow you to say, oh, okay, 12 times 3, 12 times 2, 12 times, that bracket doesn't allow you to do that. You just need to multiply the 12 into here, and that's good enough. And then it will get into here eventually, okay? So 12 times 3/4. So the way I do fractions, like I know I showed you that, just multiply it to the top. For me, I go 12 divided by 4 is 3. 3 times 3 is 9. So that's 9 brackets 2x minus 3 equals 12 divided by 6 is 2. 2 times 5 is 10. So that's 10 negative 2 minus 4x. That's when you become good mathematician. You could do this really fast, but we'll go this slower. So I said when you multiply a whole number into a fraction, you only multiply it to the top. So you get 36/4 times 2x minus 3 equals, and then 12 times 5 is 60/6 negative 2 minus 4x in brackets. 36 divided by 4 is 9. And then you have the 2x minus 3 equals 10 negative 2 minus 4x. Okay. So that's exactly that, except for me, I did it in one step. So if you're quick and you could do this quicker and you start becoming good with fractions, you should go straight into that. But also it's okay to go through that step. So when you watch the video that I do about fractions, I tell you always, when you're multiplying a whole number into a fraction, you reduce the whole number with the fraction. So the 4 goes, the 12 becomes 3, and that's what you multiply it into the 3 there, and that's why you get 9. You multiply it into here, you reduce the 12 and the 6, 6 goes into itself once, it goes into 12 twice, 2 times 5 is 10. So if you become good with fractions, you could do it that way. And it's okay to go through this, just the numbers get a little bit bigger, but that's fine. Yeah. So now I'm just gonna take it right here. I'm just gonna close that up in a box. So the distribution property here and there, that's 18x minus 27 equals negative 20 minus 40x. Okay, so 18x minus 27 equals negative 20 minus 40x. So 10 times negative 2 is negative 20, and 10 times negative 4 is negative 40x. Now we want to bring the x's all to one side. So I want the x's to be positive, so I'm not going to bring the 18x this time to this side. I'm going to go 18x because it's positive here, plus 40x, because when you move the negative 40 to the other side, it becomes plus 40, equals negative 20 plus 27. So this, because it moved to the other side of the equal sign, it becomes plus 27. The negative 40, when it moves to the other side of the equal sign, becomes plus 40. So now 18x plus 40x is 58x. Negative 20 plus 27, that's 7. You have to divide both sides by 58 to isolate for the x. By 58, x equals 7/58, and that's the answer. So thanks all for attending today. I'll see you next Sunday. Till next time, bye-bye.